Hello, everybody, and welcome to the last session of today, probably the best session of today. It's the HCL Domino on Docker and more. My name is Thomas Hampel, and I'm the one of the speakers of today. With me today on stage is my colleague and friend, Daniel Nashed. Can you say hello to the audience?
Hello and good afternoon. I'm Daniel. I've been at the conference last year and I'm enjoying to be here today, like we were here yesterday. And I will do the technical part, the demos, and I hand over back to Thomas to get right into the topic.
Yes, and just to conclude, I'm still Thomas Hampel. I'm the director at HCL Product Management. I'm responsible for the Domino server, Nomad, and all things security. Like Daniel said, we did attend the Russian Nodes User Group conference last year, and we did an interesting conference, an interesting talk about Domino on Docker. It was called the Domino Docker Bootcamp. This year, we would like to go beyond just Docker and want to deep dive into it. So this will be a rather technical session, hopefully with a lot of new stuff for you. So since we have quite a number of slides and also a couple of demos for you, let's start. As usual, the legal disclaimer, you know that we are going to talk about future products, future development, and that these products may change. So please be aware of that. So let's get to a starting point. Actually, in the IT industry, we all like to install servers. We all like to do things manually. Well, not really, you know that. Meaning we all want to have a software or a solution that is easy to deploy, meaning want to save time to deploy. When we deploy a solution, it needs to be reusable so that when we have to do the same thing again, that it is consistent across the implementation, meaning if you install Domino, for instance, you want to make sure that with your second server, the settings are exactly the same as with the first server. And last but not least, we all want the total cost of ownership to be reduced. And there is a solution to that in the IT industry. For time to deploy, it is, of course, automation. If you automate a task, it will run unattended, it will run automated, and will save a great amount of time. For reusability and consistency, well, the solution is standardization. Standardize and harmonize the settings. And of course, for cost reduction, let's go for resource optimization. There is innovation ahead, and as the title of this presentation indicated, it's about Docker. And Docker, meaning containers, make a difference to how fast you can deploy a solution. And the real difference, I think, can be explained by just looking at one of the documents, one of the red books. No, actually, it was a presentation from my colleague Frank Altenburg back at IBM. He did a presentation about IBM Same Time version 9, complete feature installation from zero to hero. If you work with Nodes and Domino, you remember this presentation because it had 970 pages that you had to follow step by step in order to install the product. Now, containers make a difference because in the Docker world, we've just released Same Time 11.5 and installing somewhat of the same environment, meaning installing a Same Time meeting environment, literally just takes these 4 steps. You install Docker, if not already present, unzip a zip file, provide some configuration values, run the install shell, and you're done. So it just takes a couple of minutes to complete. Now you will realize that when looking into the Docker and container world, all of a sudden there are a number of new technologies, a number of new logos popping up that all, well, seem to be quite confusing. Yeah, Containerd, Openshift, AWS, Rancher, Creo, Helm charts, and so on and so on. And this is just the beginning. I mean, if you look at the cloud native landscape, the Cloud Native Foundation has created a landscape drawing here, and there are some more logos, even more technologies out there in order to help with the problem definition earlier on, meaning to standardize your deployment, to automate, to scale your deployment, all with the goal to make it easier to run your business. Within today's session, we would like to help you to understand some of these technologies and how to put them into perspective, especially in the context of Domino. And for that, we would like to start with this little decision flow. So really, if you get started, if you would like to deploy Domino in Docker in a container environment, you would start on the left here with this circle. And if it's just something you want to test, something you would like to play around with, maybe Docker desktop is enough. That's something that runs on your computer, it runs on your desktop on a small machine, and it's enough to run a Domino server locally, and it's perfectly fine. If you want to go into production level, running a machine all around the clock, then maybe what you want to do is to see the entry level, and that's a Docker server. For production hosting, that's quite fine. Now, it's getting a bit more complicated if you want to scale, really. If you want to scale out to thousands of users, hundreds of thousands of users, want to scale to massive amount of workloads. And here, in our opinion, there is a decision for you to make. And the decision is if you want to spend some money, because Kubernetes is one of the orchestration platforms you can leverage, which is open source, and you can use it. But you can also go with one of the commercial solutions like Openshift, Rancher, Platform 9, VMware Tanzu, and so on and so on. And there are quite many. Yeah, and we would like to help you to get to know these environments a bit more. And that's why we have to start with some technical details at first, and then we leverage this in the following slides. So just a little repeat why Docker is so interesting, why containers are so interesting. It's because in the container, you only have the actual application and not anymore the operating system embedded. That means instead of having to install a full operating system, instead of having to maintain an operating system, a container only encapsulates the application. In our case, that would be Domino. And you can then take this container, or well, you can take this image from one environment to the other and repeat the same installation steps by just applying the image to your container environment. There are some technical terms that I need to explain, so that's why this following slide. So let me explain. In the Docker, in the container world, there is a so-called image. This could be a base image, it could be just an small operating system image, it could be a Domino image, which, like I said, encapsulates the application in a small image that is ready to run. And you can compare this with a CD-ROM or DVD, which is like a piece of software that is not running. So it's just the software, it's not running. That is what an image is. The image is hosted in a Docker registry. The most well-known registry is the official Docker registry at hub.docker.com. And what you would do in your environment is you will have a Docker host, a machine that runs Docker. And when you do so, this machine will run the Docker daemon task. And you have a command line client or some form of client to communicate with the Docker daemon. This client can be leveraged to send commands back and forth, like build, pull, and so on. And by sending a command, you can say download an image from the registry down to your local image registry. In my case here, this graphic, this image shows a Domino server logo. This is one of the images that we're providing. And by saying Docker run, you start the image and you create a container out of it. A container is disposable. That means it doesn't have any persistent data. And for Domino, we want data to be persistent, because whenever you restart your server, when you restart your, when you recreate the container, you want the Domino data directory to be still present. And that's why we need so-called Docker volumes. So these are a few technical terms in the beginning. I know if you haven't heard about this before, it's a bit complex to understand. And that's why Daniel and me thought, especially for Domino administrators, it might be helpful to have a little dictionary in place. So we came up with the idea of creating this translation dictionary to translate between the Docker world and the Domino world. So when a Docker person is talking about an image, that's the same as a template in Domino. Or in a Docker container is an application in Domino. It's the running instance, and so on. We are going to add more terms to the slides as we go along. But I think, Daniel, you would like to explain what we can currently do, what we have available in terms of Docker images for Domino. So, Daniel? Unmute.
I'm sorry, I was muted. So we have two different Docker images. One is the official Docker image from HCL. This is the one that you can download from FlexNet, and this is the one that is also available as a technical preview for early adopters. It's the early access program, and this image is built on the Red Hat Universal Base Image, and it runs on Docker currently. That's the only supported platform, and it will work later on with release 12 on all different environments like Kubernetes, Openshift, and Potman. At the same time, or earlier started, Thomas and me had created a GitHub project where we already started with release 9.01 to deploy Domino on Docker with a community version of the image. So we took all the feedback from the community and built it into a Docker file, which is then a Docker image when you build it up on your environment. So that is like the playground and the sandbox for new features, and we're taking that and giving feedback to HCL internally to make features available, maybe in a little bit different way than what we did initially, because it's a community project. And you will see one big step ahead in our demo, where we will show ideas that came from our project and which ended up into a feature that is part of Domino release 12. So our image it's not really an image, it is like a Docker file, a project where you build your own image based on what is in our project. And it has a couple of features that help you to get your server up and running, and to maintain the server, update the server. So it's still a valid project, and you can use both projects. You can test with release 12 using the official image, and you can run our image in production. So we put together a couple of slides explaining you what options you have, and I will just go through this quickly. Depending on your operating system, you have different options. On the Mac, it is the Docker Desktop for macOS, which is very simple to install, and it comes with Docker Compose included, a small Kubernetes single node cluster, and it's really good for developers to look into it, and also for customers to start looking into Docker and different images. So this is really a starting point, more for personal use. And then we have a Docker on Windows, and Docker on Windows is using Windows virtualization technology. So at the end, in the backend, it's all more and less Linux in all the cases. Whatever we show you, the baseline behind it is always Linux running a Docker daemon when we talk about Docker. And this is then combined with what your operating system provides. A next more interesting step is Docker on the Windows Linux services version 2. And this gives you even more integration into what Windows has to offer, and also what a Linux subsystem has to offer. And so you have the best of both worlds. So I'm using that on my machine. It took some time to set it up, but once you have it running, it is really interesting for develop your own applications as well, not just run our images. I think we have another slide. This is where you see exactly where that you can talk to the Docker daemon even from an Ubuntu command line prompt. We put all the information into links on the website, on the pages, so you can go back later on to look into details. So we're just skipping quickly over them. So the next option.
I think we should say that if anybody has a question, of course, they can use the chat capability to ask the question. We have a small Q&A section at the very end.
Right. So we skip through this quickly because this is only to give you an idea. So we have the next level. This is still on level 1, but this is really, no, can you go back one slide, Thomas, please? So this would be on your machine, in a virtual machine, have it installed on your machine using containerd, and this is a native Linux in the backend. And it works very similar, but it is already without Docker Desktop, it is running your environment. And the next level, which is really a Docker server, this is something that you can run in production. It's a hypervisor like VMware or any other hypervisor. You run a Linux distribution of your choice, for example, CentOS, Red Hat Linux, and then you use Docker Community Edition 19 or higher. 18 will also work. And this offers you a server environment already. So this is good for small environments, but this is nothing to run a whole company on it. That's the next level. The next level is plain Kubernetes, as Thomas already started to explain. Kubernetes, or there's also a smaller project from that is also a community free version. It's a lightweight distribution that even runs with 1 CPU and 2 GB of RAM. It's the K3S distribution, so it's derived from Kubernetes, and it's a smaller deployment that we also used successfully for workshops a while ago. So this is the vanilla plain Kubernetes. The advantage of it, it's free, but on the other side, you have to do many things on your own. That's where the next level comes in, which would be the commercial versions, and there are many of them. And Rancher is one of them. This one, I have it running on my machine. It just needs 8 GB of RAM to start with. 2 CPU cores are fine for the beginning. And then the next level we have, or a different one, a different flavor, is Openshift. Openshift comes in a commercial version, but there's also an open source project, the OKD community version. And this is really an environment that is designed to scale. It takes, the minimum installation takes 3 machines with 16 gigabyte of RAMs each, 4 CPU cores, and 120 gigabyte of disk. So it doesn't install without that. Just to give you a dimension. So it is really only for larger deployments, and it's quite expensive. But this is something many customers are currently looking into because, I don't know, they might think more expensive is better. So my choice would be probably something else, but many people are looking into that right now. So that's something for Thomas, right? So you want to explain the terminology behind Domino admins and put that into the Kubernetes world.
Yeah, we are going to explain this after the demo again, but I'm just advancing my dictionary here to help our Domino administrators to understand the different terms in the container world. So here on the right-hand side, you see new terms that come up in the Kubernetes world, like node or a pod or a kubelet. And the funny thing is, it all relates to an existing term in our Domino world. So if a Kubernetes administrator is talking about a node, that is similar to when a Domino administrator talks about a Domino server. Or the etcd here in the middle is the same as your Domino name and address book combined with the cluster DB directory, CLDB dir. And if a Kubernetes admin is talking about a YAML file to the lower end here on the left side, a YAML file is exactly the same as your perfect Domino documentation, which I'm sure you all have, right? Let's be honest. So you already get the idea that by having your environment perfectly documented, and that means perfectly described in a so-called YAML file, it's a text file, it becomes repeatable. So when you have to build the same in another environment on another customer, you can just replay the same YAML file to this environment.
And I will show that in a minute. No?
I was just about to
show
say
a YAML file in a minute.
Yeah. So just as a small starting point for you to get an idea on what is the adoption of containers in the yellow sphere, meaning in our environment. So of course, at HCL, we are using Docker, we are using containerization for our internal product development. Especially, it's very, very useful for automated product testing. And when we build our software, it is time consuming to install a full server on a physical machine or even in a virtual machine in order to do product testing at the end. What we do is to spin up or to start a container, do the testing, and then destroy the container because our test is completed. That is significantly shortening the software development life cycle. Also, you've heard this earlier on, we have a project called the HCL Software Factory, SOFI, where customers can run our products in Kubernetes-like environment. That's also all based on containers. Our business partners are using containers for a great extent. To be named here in particular is Factor Y in Italy. They have fully automated the Domino server deployment on Kubernetes and are offering cloud hosting services for customers who want to leverage Domino. Of course, for a business partner, the benefit here is because of being highly automated, they can quickly onboard new customers. They can quickly upgrade the environment. And for the DNUG, which is the German Nodes user group, Daniel, you can probably say a few more words.
Yes, they're running same time 11.5. Currently the preview, and this slide still says it's about to be released. It has been released. The same time premium has released. We're running this in the DNUC, and as we shown earlier on the slides with the many pages for same time installation, this is really, you download the software, bring it up to the server, configure it, and then you bring it up and it just runs. And the upgrade is a similar experience. So it is not just the installation that saves you time, it's also to maintain the environment. So, and also the next one, a large Domino customer, I'm also working with them, an insurance company, and they want to move the in-house Domino applications and host them on a hosted environment on Kubernetes. And last but not least, I'm working with a business partner. They do mobile application developments for a traveler client, and they need all kind of different traveler versions for their testing. And so after I installed the second server, I came up and said, guys, how many versions will you need? So we can take that endless time. So what about using Docker? And then I took their server and I put the Docker host on it. And now they can put any Docker, any Domino and Traveler combination onto their server, which is extremely helpful. So they don't have to install, they just take the image and apply it.
It sounds very special. It sounds complicated, especially because of the introduction with all the technical terms. But at the end of the day, it's really simple. And we're going to do a demo in a minute. I just have to explain what we are going to show in this demo. So remember the different components of the Docker environment. What we would like to focus on is this box here in the middle, where we take an image, a Domino image. We are going to start a container, and the Domino data directory will be located on a separate volume. And you might say, hey, wait a second, Daniel and Thomas, they have done this demo already last year. That's true. We have shown how to start a Domino server in Docker. So this year, of course, we have to be better. So we are advancing this demo and integrate all the latest and greatest features which we have lined up for Domino. So what we are going to do is to show you how to fully automatically start a Domino server, provide the server name of your choice, of course, create the data directory, create the server ID, complete the server configuration, and deploy an SSL certificate fully automatically on your server in the container, and also create an ID vault, which, by the way, was never possible before. So for creating an ID vault, you always had to manually take some actions. So now this is all possible just with, I would say, a one-click, one-touch configuration, so that after just a few seconds, you are up and running with your environment to serve your nodes, Nomad clients, your browser clients, whatever you like. And Daniel is going to do the demo. So we now quickly have to switch screen. If we don't mind, Daniel, feel free to
I'm grabbing,
take over.
I'm taking that screen, share. So here you see, so it's all Linux, right? So I'm on a Linux machine and I have prepared an empty data directory. It is not a volume, it is a local file system that makes it easier. And you can see there's nothing in the file system. Then on the next screen, I show you that I have prepared a YAML file that Thomas was talking about. And a YAML file is describing your environment. In this case, it's describing a single server, but it could be a service with multiple servers where different servers work together. They share the same network on on your host. And this is a file that I use with Docker Compose, which has a very similar syntax to what you would see when you use Kubernetes to define your pods and services. So it's very similar. And what you see here is that I'm using a Domino Docker image. So this is really the latest and greatest version 12. I give it a name. I give it a host name. I tell it, and this is really special and important for Domino, I tell it to wait on shutdown at least 60 seconds because Domino takes some time to stop. And this is the base definition of the container. And I give it a name, right? Domino Lab. So, and the next part is really already the environment of the server. So that are environment variables that the Docker container can consume. And this is the new stuff, Thomas, really. This is the one-touch Domino configuration that we're using here. And you define your environment. Before, we used this similar things on the community project, where we took all the variables and pulled them into PDS files for setup, which is really not what we want. This here is a new feature that came out in the December code drop. It's really fresh. It's brand new. And we're the first one to show them that live on stage. And those environment variables here are read by the core Domino server on startup at the first time, and it will create the server. It will give it an organization name, certifier password, and so on. And it also will go through the other steps that you know from a server setup. And in this case, it even registers 3 additional servers, give them certain names, and put the server IDs into a certain directory. And as Thomas mentioned already, and this is really great news, and we waited for that long time, we can automatically set up an ID vault with the first server configuration. And this is not Docker only. This is something that we could also do with a normal Domino server. And then last but not least, we have the definition of the environment, like which ports are used. In this case, I only take the NRPC port, which I map to a different port, port 80 and 443 that we will need for the certificate, right, for creating the certificate. And then we have the volume definition, as Thomas mentioned before, and that's all that we need. So in the next window, I show you, I have this empty data directory. We had that before. And here I use Docker Compose. I provide the file name and I say up. That's all I have to do. If I run this, and on purpose, I'm running it without setting it to the background so that you see what is actually happening inside the container. So this is really preparing the Domino server setup. It will take a moment. It created the environment. And now you see the started server. It already loads the DSRP filter because that's part of the automation that is built into this new cert manager, which is part of Domino 12 that takes care of all kind of certificate operations, like the Let's Encrypt operation and everything else. And you see that the server task restarted the server, the HTTP server, and now it's ready to go for creating a certificate. So we can look meanwhile what happened on the server. Oh, it's already happening. So it created an account document for the ACME protocol for Let's Encrypt production, because this is what I defined. You see it's waiting 5 seconds for the challenge, for the HTTP challenge to be in place. And now we have a valid keyring file. The HTTP server is restarted because that is still needed in this build. Later on, this will work on the fly. And you could hit a web browser. Let's see if I have one. So Moscow. Let's take the name. I hit the wrong web browser. But you see, it's up and running. It has a proper certificate. Oh, it doesn't show that. It's the wrong one. I take this guy. So here you see it's a proper certificate. You can open it. You can look at it. It's verified by Let's Encrypt. And you see you can see the certificate. It is a proper, valid certificate with everything on it. Thomas, how is that?
Damn cool, because not only can you automate the Domino server setup, the base configuration, but you can also hook in the latest improvements on integrating Let's Encrypt and combine one with the other by using the latest Domino Early Access program that will be released, I think, next Monday. So the demo that you have seen just now is
no, it's released already, Thomas. It's all there.
Oh, okay. So
it's the December code drop is already out. So I took the December code drop almost.
I'm talking about the blog post, but okay, yeah.
But the December code drop is there. This functionality is already there, and everyone can download it from FlexNet. And you also see here the ID vault has been created. So it's all there in place, up and running. The server is running, and we can work with it. So we have many different steps working together, and you see where HCL is bringing all the functionality together, and they take the feedback from the community, what we like to see. The ID vault, for example, was something that we requested because we need this for many different things like the app dev pack and also other applications.
Cool, awesome demo.
So back to the presentation. Do you want to take over again?
No, you can just continue the slides. I just wanted to recap on the chart on the next slide.
If PowerPoint likes me.
Yeah, then let me take over.
Oh, here it is.
Okay. Well, yeah.
So here's the demo. The next part is the Kubernetes Docker. We first talked about Kubernetes, and now Thomas takes it and brings it to the Kubernetes world.
Yeah.
Just let me.
What I wanted to say is the image that Daniel was just using and the YAML file that he was applying here is not limited to a Docker container. It's not limited to being Docker, even though it was a Docker compose. The same concept can be used in Kubernetes, can be used in Openshift and others. Because if you remember the presentation we did last year at the Russian Nodes User Group 2019, that was still a long command line that you had to enter in order to configure everything correctly. So as soon as you try to deploy multiple servers and do the same thing over and over again, you're asking yourself how you can use, how can you automate this? How can you orchestrate the environment to scale faster, to be more flexible? And this is exactly where now all the items are coming together. And the next level, as you've seen in our slides before, is Kubernetes. And on Kubernetes, there are some more terms, some more technical terms that come into play, which we have to explain. Daniel, can I take the screen share again?
Oh, I thought, sorry. If you want to, take the screen share.
Yep.
But I can advance the slides if you want to.
Okay. So in the Kubernetes architecture, I mentioned it before, there is an individual Kubernetes node. So that is what we would say is similar to what a Domino server is. But Kubernetes puts a whole new management stack on top. And with the demo that Daniel just was showing, you realize that it is going to be it's going to add a new level of management capabilities, because you only have to manage the YAML file, the description, so to say, of what you want to deploy, so that the components here, and we're going to explain them in a minute, can make sure that your workload is being put onto a Kubernetes node to scale out. Let's for sake of simplicity, let's look into this a bit more by going to the next slide. So let's say you have a Kubernetes cluster in place, and there is a container that we just talked about. So this is something that you've already seen, but in Kubernetes, it needs to have a management interface. So next slide shows the next.
And Thomas, the interesting part is it's exactly the same container, it's the same technology, it's just living in a different context. That's the important part here. So we're talking about the same functionality, it's the same image, and what Thomas is showing here is just the pod is like the next level. It's something around the container to be managed by what Kubernetes is using. Mm-hmm. And that's what is coming now.
Yeah, so the smallest element is the so-called pod, which is the container and a little bit of a management on top. And you can, in Kubernetes, you put this into something that's called a deployment. And a deployment can consist of one pod, but it can also consist of multiple pods. In this case, the first pod has been assigned with an internal IP address and an internal port. And if we advance the slides further, you'll see the same application can have another pod for load balancing, for scalability, and so on. The difference here is the IP address, as you can see, IP address 10.0.0.1 and 10.0.0.2 for the second pod. Both pods have a label, in this case, just for simplicity, my app. And if we go one level above, on to the next slide, you'll see the Kubernetes describes this application as a so-called service. So it knows which container will receive the traffic if you define the selector to be my app. And it knows, okay, if this pod is no longer available, it can then reroute the traffic to another pod, which is a clever technology. And this service is internally addressable on an IP address, on a port, but it's still internal. So in order to be accessible from the outside, you have a public IP address and a public port that is being routed through an ingress controller where you define which URL, which address will be routed to which service. Yeah, and putting all together, that allows to assemble quite some complex applications, because you could use this pod for my app, and then if we advance it further, on the next slide, you'll see you can add another container for a different service called foo in this case. So it all assembles one big enterprise environment where Domino can certainly play a very interesting role for your application and mail capabilities.
So those are the basic principles that every different Kubernetes environment or other derived application like Openshift, Ranger, and everyone else who's writing applications on top of Kubernetes, they use all the same principles. So it's not just Kubernetes. And that's why it's so important to understand the difference.
Yeah, and when it comes to scale, of course, there are endless capabilities. For our Domino administrators out there, I just wanted to revisit this dictionary slide because we found this to be very helpful in workshops that Daniel and me were giving for you to understand what these different terms mean. So, of course, this small 45 minutes of a presentation can only be the introduction to this large topic, but I hope you understand that the Docker container image, the image that HCL is providing, is not just limited to Docker. It's a much broader world that we're tapping into with a lot of interesting, flexible capabilities that is exciting to be leveraged. Yeah, especially having seen Daniel's demo where he built a complete server completely from scratch in, how long did it take? Less than a minute, I think it was.
Right, because it had multiple steps and also that templates had to be unpacked and everything was like, I would say a minute.
Mm-hmm.
So in the Kubernetes world, we have some other details that you might want to explain as well. Like we have a bigger picture here, but maybe we skip those slides.
For the sake of time, we probably want to go straight ahead into the recommendations for Domino slide and then directly to the Q&A slide. So yeah, the gotchas. What have we found? What would we like to provide you as advice to start with? Well, first, I highlighted this in bold because whatever you do, it is always Linux. It's always one form or the other of Linux. And it also is always Kubernetes. If you go to the enterprise scale world, whatever it's called, if it's called Rancher, if it's called Openshift, technically what it runs on is Kubernetes. And so don't be confused with all the technical terms that we've been using. It will get together quite nicely. And I mentioned this in the translation slide earlier on, that YAML is the file format that describes your environment. So that means YAML replaces PDF, meaning PDF is your perfect documentation. By writing down everything into a configuration file, you'll never have to worry about, what was the change that I have applied to my environment, because this can be rolled back and forth. So it's a real nice technology.
So it's a definition of a container, and it can be used in the same way in your test environment and in your production environment. You can work, that's something that we didn't show, you can work with variables. You don't have to specify actual names. And so you can use the same YAML file in different environments. So that makes it even more interesting here.
Mm-hmm. Yeah, and our goal is not only to make Domino running in a container, because that's what we can do since years. The goal is to have a fully managed container. And this is in order to achieve the goals that I explained in the beginning, meaning time to deploy, repeatability, consistency, and of course, reducing the total cost of ownership. If everything is fully managed, that will greatly simplify your life. Small summary on lessons learned from our workshops. Domino, by definition, by the product what it is right now, is not a microservice platform. Domino itself is a platform that unifies different services into one product. So by using Kubernetes, Domino is not going to be split into pieces by definition, but by using the container deployments like we just explained, Domino can greatly benefit from automation and reducing the total cost of ownership by using containers for deployment.
And Thomas, it's not just Domino, it's also add-on products like Traveler, and we have in our community image, we have the Vault image, where we do a complete Vault configuration with the first container. similar to what we have just shown in the demo today.
And another small highlight, when a Domino administrator is talking to a Kubernetes administrator, please be aware you don't speak the same language. Even though you may even have completely different mindset, but the translation dictionary that we've provided in this deck here is being of great help. So keep that at hand, and I'm sure by talking to each other, you will understand the other side. All right, concluding the slide and then hopefully spending a few minutes on Q&A. Just a quick one about this slide. Small reminder, high availability. Kubernetes offers clustering, and clustering in Kubernetes is a great technology, but it does not replace Domino clusters, because one is on the application layer, the other one is more on the layer below, and there is a lot more that needs to be done in order to leverage Kubernetes clustering. So you want to keep Domino clustering in place and use Kubernetes clusters as well. In short, one size does not fit all. When you plan out your deployment in Kubernetes, when you're making your steps into this direction, please reach out to the community. There are some great people out there that can provide you with help. We have done a number of sessions and can, of course, provide best practices. But please don't miss the opportunity to take a look at what containers can do for your deployment. So,
also, Thomas, what we should note, we have some examples for Kubernetes deployments, Kubernetes definitions of the container in our community project that can be helpful as a starting point. And we will add to those examples with new versions. So we will put also out that example that we had for the conference in a similar way to our community image, and because we couldn't do that before because we didn't want to spoil the demo here. So, but we will put this not only into slides, we also blog about it and give you all the details how we do it, and with the one touch. There will be more things to discover than what we have shown.
All right, then let's go to questions and answers. So I need to ask our moderator, who has been carefully monitoring the questions that come in. Oh, hi, there you are. Hi, Vlad.
Hi, Thomas. Hi, Daniel. Hi, everyone.
So have you been receiving any questions?
Sure, but before we go to Q&A, we have very special thanks to Daniel. We have people posting not a question, but they want to thank Daniel for everything he does for Domino, for Linux, for his commitment.
Thank you.
Yeah, a lot of you are doing great job, and thank you, Daniel, from our community.
Thank you, very reserved. Thanks.
Absolutely. Thanks. Congrats to Daniel.
Yeah. We have questions. I will put them in a different sequence, so it will be more logical. What is your impression? Docker is meant for production or only Kubernetes, or what is your point of view on that?
So let me take that. First of all, there are some confusions in the market. What's happening with Docker and where the direction is. Docker. The title of this session was Docker, but it should have been containers in general, right? So we are always talking about containers and not just Docker. And Docker as a product is not the only option to go, even if you local. So there's another project that we didn't mention here. It's called Potman. And Potman is an alternative solution for similar to Docker, but on a different base. It doesn't need a daemon, and it can be also used to build images. And that's, for example, something that Red Hat is in favor of. So I don't think Docker will play a major role in future. They have done similar mistakes like BlackBerry. They were really early on. They have been a great company, but now step after step, others are progressing faster than them. So I would not take Docker as a standard anymore. So Docker is interesting to build your first containers. So it's a build platform and a runtime platform. And as a build platform, it's still really relevant. Even Potman is something that is advancing faster than Docker. But if you do real-world deployments, you should at least have a Docker server, as we shown as level 2. And even better is directly move to Kubernetes, because this is what in future is to be used for many different services at the same time. So Docker itself is more the entry level, and also Potman would be the entry level, and Kubernetes or any other enterprise Kubernetes infrastructure based on Kubernetes, like Openshift or others, would be what I use.
Yeah, so then let's make this clear again. The image we are talking about will run on all platforms. It will run on Docker, the same image will run on Potman, will run on Kubernetes, will run on OpenShift, and you name it. So you don't have to build an own image for each platform. It's just the same image. They all use the same image.
And also there's something interesting, and I did a blog post a couple of weeks ago about Potman. So the Potman project takes a bridge between the Docker world and the Kubernetes world. Because when you look into Docker Compose, what I've shown in the example, the Docker Compose syntax is a bit different than a pod description in Kubernetes. And Potman is able to capture the definition of a container and describes that in a pod description. So they're trying to bridge the world between the entry level and Kubernetes. So, and I think this is the interesting part. This is where it's leading to.
Quite a long answer to a simple question.
No, but I'm giving also the context about what is happening around it, because that would be probably one of the next questions. What's going to happen with Docker? So we had 2 steps. The first step, the Docker Enterprise was going away. And now we have Docker Community Edition still there. And they are really doing a great job with documentation, enablement. The website is great. And so Docker is a very good starting point if you look into container technology as a beginner. But if you look, and that was the main question that you had, if you look into real-world enterprise deployments, you should probably directly move to Kubernetes.
I see. Thank you. And we have more questions, actually. So if you are a service provider, should you, so I assume you should do something more like Kubernetes, right? From the previous answer. So you should not...
Yeah, you really have to, because one of the slides earlier, we had the situation that Domino is special. Like when you look into what Thomas has shown earlier, with the ingress and the service and all the definition, this really works well. Do we have the slide quickly? Here, this works really well for a web application, but this doesn't work well for Domino, because Domino has the NRPC port 1352, which cannot be dispatched through a load balancer easily. So that is something that works better with Kubernetes and definition of multiple services. So you will have one service with one IP addresses as for each of the Domino servers. And if you're a service provider, you really have to separate the different services, not just from the network level, but also from the pod level. And that's something that you can't really do with the Docker environment. So if you want to scale as a service provider, you have to use Kubernetes.
Yeah, if you've been listening carefully to our presentation about my presentation about Nomad and the presentation we had about safe links the other day, you'll see that, of course, Kubernetes is built for the HTTP protocol stack. And what we are doing there is to encapsulate the nRPC protocol into HTTP, meaning into WebSockets. And thereby, Domino can leverage all of this technology. And of course, Domino also provides the HTTP task. So anything goes, anything related to a Domino web application would just work fine. So like I said, it can become a bit more complex. Planning is everything. So let's get in touch and let's talk about the details. Clearly, there are service providers out there that are currently running on Kubernetes and serving a large number of different customers, where each and every customer needs to be isolated from the other customer. And that is perfectly running in Kubernetes. So yes, please go for it.
Thank you. And we have more question, and I think you definitely have an answer as far as you know. So the image includes just Domino, and concerning the custom applications, how should be they should be added. So as far as I know, Thomas, you with Daniel made a JSON file, and it allows to pre-populate as well custom applications. Can you please shed some light on this?
Yes, so last year we did a demo at the Russian Nodes User Group Conference in Moscow, where we have shown our community project to automatically install a Domino application into a Docker container. This is a community work. This is a prototype. So let's make sure that we do not mix this up with the official HCL Docker image, because the Docker image that HCL provides does not include this function yet. However, Daniel said the prototype we are doing, we are learning something new there, and all the good features and functions we're trying to leverage them in the official HCL image and provide more functionality in the official image. Now, so what you can do today is, of course, to take the existing HCL image as a base image, and then add your file and combine both to become your own image. So that means you're creating your own image, and you can deploy this with your application pre-deployed. That can already be done now.
But Thomas, to be clear, we have customers and partners using our community image in production. So it's a real world image. It can be used in production, and it's leveraging a standard installer. So it is a valid and supported environment that you can run today. And that offers you additional scripting to install your application. But then, and what we will do, of course, is as soon release 12 is released, we will provide only the delta between what HCL offers and what the community wants, right? So you will see our community edition, the community image to update over time, and we will have some shift depending on what functionality is in the product itself. So we replace all functionality that is already there and take the best of both worlds. So I would definitely go for it and have a look into it. And as Thomas said, you can always take an image and base your image on top of that. And that depends on the application. If you only want to add a database, then it's easy. Then you can use our project. But as soon as you have to deploy own binaries, those binaries really need to deploy it inside the container. And then you need to build an add-on image, which can be also done with our project.
Watch the replay. There are a couple of examples out there, videos on how to use the GitHub script that we did to deploy your own applications. So it's all available out there. And maybe it's a call to action. If you are interested in adding more functionality to the Domino Docker image, please join the GitHub project, contribute your ideas, also contribute your ideas to the Domino Ideas platform, to the Ideas portal, domino.ideas.aha.io, and post your ideas on how we can improve the product, because we would like to make sure that you are successful in the market and you can deploy your Domino servers and applications in a broader scale much faster than before. So with that,
and in fact, Thomas, many of the features that we see in release 12 are coming from the AHA ideas, right? So
yes.
I see many of my special favorite features that are coming up, and Vlad, you probably also have some that you already seen, right?
Yeah, right.
So it's really working, and thanks, Thomas, for that.
Thomas,
I think we're running out of time. I think. I mean, Vlad, you are the manager here. More questions or?
Yeah, we are behind the schedule, but we have two maybe final questions. They are.
That's fine. We're here.
So, Traveler on Docker, is it possible? That's one question. And the second, we can think in meanwhile. There is a question, which Linux distribution you suggest to work on? And I can do my side comment. At some point, I think in IBM times, the SUSE was discontinued, right? Not actually discontinued, but Domino was supported, but some new products like Verse, like Vault, they are supported only on Red Hat and CentOS. So,
okay. So two questions in one. Well, first of all, we have seen that deploying an application like Domino in Docker is much easier than having to install everything yourself. And of course, the Traveler team wants to take a benefit of this and also is working on a Docker image for Domino V12. So today, there is no official HCL Traveler image for Docker, but we're working on that. So if you are interested in deploying this, stay tuned. It's about to come. If you want to go for deploying this using the GitHub community scripts, then we have a script ready that can already create a Traveler image for Docker. So see the URL in the beginning of the slide deck. So it already is there. Now, the second question about Linux support, I think it's in using containers, it becomes more and more clear that it does not really matter what it is based on. Yeah, in the traditional software development world, we have to test every single operating system for compatibility. And IBM, back in the days, decided to limit the number of Linux distributions to just Red Hat and SUSE Linux. So HCL had to fight for getting CentOS supported, and soon with V12 we are intending to broaden Linux support to go beyond that. The idea here is to say the Linux distribution needs to fulfill certain base criteria, like a certain kernel version, certain libraries need to be present, and if that is the case, Domino will run in there. The actual installation instructions may differ from Linux distribution to Linux distribution, and we are hoping for the community to help out with testing Domino on a broader set of Linux distributions. So I guess we have someone who is going to help out for testing and certifying Linux distributions in Russia and beyond. So and other than that, you have seen that the container we were just running in the demo, the container internally was running Red Hat UBI as a base image, but it does not matter what operating system you run outside of the container. So really, you can standardize on your operating system of choice and still run the Docker image that HCL is providing you with. Hope that answers your question.
Yeah, thanks a lot. And before we finish today, we want to thank Daniel for effort with Astra Linux, because we started this test. I do remember I was cooking for my kids something, and Daniel pinged me in the morning, what is hot in in Linux area, and why? When I finished cooking, Daniel said, "Oh, I already get a Linux up and running. It's really cool. It even has a German UI." So yeah, Daniel, thanks a lot. It will really help us to move and continue with Domino in government. And also other companies. So thank you for Astra Linux support, and you, Thomas, as well, because we know that what you did to make it to make it happen.
Stay tuned for more. We are looking forward to release Domino version 12 in the first half of next year. We are hoping to run a launch party, or at least a great announcement, and we are looking forward to see all the attendees of today's session, or this week's RNUG conference, at the version 12 OGS party, so to say.
See you. Thanks a lot.
Thanks for this, and
Thanks.
have a good rest of the day.
Yeah,
Thank you.
thank you.
Bye.
Bye-bye.
Bye.
Bye.